Hey guys, and welcome back to another CATIA V5 tutorial. Today is carrying on with the wireframe and surfacing. So last video we did a wing box. Today we'll be doing a propeller. I'll also be showing you how to do a wingtip on the wing box we did last time as well. To finish off, I'll also be doing a little bit on how to edit your surfaces and any geometry using the contextual menu. And some of the tools that CATIA has at your disposal to make it a lot easier on you. So to start off with the propeller, I've got, this is all I need to make it. I've got 3 sketches just to go into them. They're just very simple splines. I've not constrained them because it allows me to jiggle things about a bit and have a bit more room to play around. Things with surfaces is you generally need some wiggle room when it comes to this to get the right shape, especially in generative shape design, which doesn't have as much freedom as some of the others. So what I'm going to do is I'm going to use the sweep function again, and I'm going to sweep a surface along this guide curve, and I'm going to limit it using this curve and a surface made from it. So what I'm going to do first is I'm going to revolve this curve here around the x-axis, like this, and I'm just going to have a bit of a play with the angles. It doesn't really matter, it's so long as you get the sweep touching it all the way through. So I'm just going to leave it at that, just an arbitrary figure. So we've got this sort of weird surface, and then I'm going to go to sweep, and I'm going to use the profile type line and subtype with a draft direction. So I'm going to choose my guide curve then as guide curve 1. My draft direction is going to be the y-axis, so we're going to pushing it out like that. The y component, and you can see it's brought up this. You can choose which way you want to project it using the arrows. And if you press preview at this point, you can see what's happening. So it's you're pulling out this curve here. Oh, wait. You're pulling out this curve here in a direction. So it's almost like an extrude really, but what it allows you to do then is to choose a relimiter. So in this case I want to relimit it to, you can do from up to, you can do from extremum, which means basically the tallest point, and you can do it along a surface. In this case I'm going to do from and up to, and my limiting element is going to be this revolving surface. Press preview, and you can see what it's done. So what it's done is it's relimited it to that. So it's a bit like a extrude at the moment, and you could have done that with an extrude, to be fair. But what you can't do with an extrude is a law. So what I'm going to do is if I click the law, it brings up this definition. So what I'm trying to do is I'm giving this a law of how much to twist this along the actual guide curve. So at the moment it's not twisting at all. If I was to choose, for example, a start curve of, let's say, 45 degrees, it's going to just stay at that 45 degrees all the way through. So it'll twist it 45 degrees and do exactly the same. If I choose a different law type, such as linear, I can get it to change as it goes down the guide curve. So it'll start at 45 degrees and it will go down to 0. So in this case, of course, we want it to stay at 0, and the end value we want it to be 45 degrees. Or I think in this case actually it should be minus 45. And we get that. Now you can either choose linear, you can choose an S-type, or you can even choose an advanced. I've never used that before, but it's where you actually define your own line or your own equation for that line. So press close, press preview, and there we have it. It's curved. I'll just hide this for you. It's curved the actual surface minus 45 degrees, and that is our propeller. And the reason I had to revolve this is so that that surface there had an equal distance from this surface or this curve at each point. And that is actually not that difficult when you know what to do. And that's it. So press OK, and there's our propeller. Now I'm going to hide these two curves very quickly. At the very tip, of course, I don't want that to be just a straight line, so I'm going to show you guys something else. And I'm going to show you something called the connect curve. So what this does is, you can kind of see, it will take two curves and it will find the easiest place to connect the two via tangential line. So normal you've got, or base curve. I just choose normal. I've never used base curve before. So the first curve, my point is going to be the point of the surface. My curve is going to be this line. So you can see the arrows pointing that way. My second point is going to be this side. And my second curve is going to be this one. And you'll see it's now produced a curve across that way, like that, which is fantastic. Now we can also change what's called the tension, so we don't have it to be like that. We can change the tension, so if you increase the tension, it will, what looks like, weirdly loosen it or give it a pull, or we can do it the other way around, of course, and have it have a tension on this side as well, which pulls it like this. Now with surfaces, it's much about what it looks like, and that to me looks like a pretty good curve. So you can make it even longer if you really wanted, but that's not very good. You can make it shorter, but that looks pretty good, like that, I think. Press OK, and now you've got the tip curve. Easy as pie, really, but that's not a surface. So what I'm going to show you how to do is then to make that into a surface. Very, very simple. You use the fill feature. So a fill surface definition, what it will allow you to do is select a series of boundaries to create a surface. So you'll see what I mean. So what I'm going to choose one boundary, this one here. You'll see it's still open, and then we'll choose this boundary here. You'll see it's changed to closed. So what I've got is I've got a full boundary going round, and all it will do is just connect that entire thing to create a surface, like so. Press OK. And there's our tip surface. Really simple as that. Now, again, what I'm going to do is I'm going to create a join for those two. Press OK. And now I've got a full surface for my propeller. Now, to show you what you can also do with things like this, I'm going to create a quick nose cone, just using a very, very quick revolve around the y-axis. Going to keep it as 180 and 180 to give me the full cone, and then I'm going to pattern it. So I'm going to create several of these. So I'm just going to hide the connect there, and I'm going to hide the fill. So I'm going to revolve or pattern this join here. So I'm going to use the circular pattern for this. Choose my join, and I'm going to choose. So if you've ever watched my videos on solids, exactly the same dialog box comes up, and it works exactly the way it does with solids. I don't think I've done a circular one, but this one is quite simple, same as everything else. So you choose your reference element. In this case, it's going to be the y-axis. Now with circular, what you can do is you can choose a complete crown, and what that'll do is it'll just space them out in a way that makes it one full revolution, and then all you have to do is add as many as you want in, or as little as you want in, to create a propeller. So I'm going to go with let's have a look. Let's go with 5, just to make it look rather fancy. And there we have a propeller. Now, of course, it's not the most perfect propeller in the world, but from that you can create solids, and you can create a very, very good looking propeller for any sort of model. So if you do want to make one from this, all you have to do is just play around with that sweep function, play around with your sketches, and see what you can create yourself. Right, so we're back to our wing surface, which we did in the last video, and I'm going to show you how to do the wingtip now. It's probably not the best way you can do a wingtip. There probably are better ways, but this is the best way I know of to get a good surface. So what I'll be doing is I'll be using a series of rotates, translates and scaling to get the right shape that I want. Again, it's one of these ones where you want the right shape, not necessarily a a define shape. So first thing I'm going to do is create a plane. I'm going to create it at the tip, which is 12,500 millimeters away. And then I'm going to sketch on this plane, and I'm going to make an axis so I can rotate this aerofoil around it. So I'm going to create a sketch on the line, create a line. So the first sketch I did it with a 1500 millimeters, 1580. Come out of that. And then what I'm going to do is I'm going to choose the rotate function on the operations. I'm going to choose my element being the aerofoil on the tip, and my axis being the sketch I just drew. So what I can do then is I can pull out this this aerofoil here. So what it has done is it's shown me a sector of the angle, which actually I don't want, but sometimes it will do it a different way. And the angle that I actually want is 40 degrees, so the angle here will be 320. So you'll see it's done it that way round rather than the other way. Sometimes it does that. Press OK. Now obviously that's not where we want it to be. We want it to be a bit further back in line with this. So what I'm going to do is, first off anyway, is scale it. And the best way to scale this is when you scale something, if you open up the scaling icon, you need an element to scale and you need a reference for it. So a reference will be a point. Now in this case I don't want the point to be any of these points back here, so what I'm going to do is I'm going to create a point via an extremum. And the way you do that is you click on the point on the wireframe and you go over to extremum, open that up. So the element in this case will be the aerofoil, and then the direction I want to do it is in the x direction, i.e. forward and back. And you'll see that the arrow is pointing that way. So what it will do is it'll look at this curve and it will find the point where it reaches its maximum on the x. Now of course I'm looking for maximum and it's going in the negative, so it won't actually create anything. So I changed it to minimum, and there we are. It has picked the very leading edge of that aerofoil. So now I've got that, I can choose the scaling, I can choose my element, and I can choose my reference. And what I'm going to do is I'm going to do it to a ratio of 0.95 just for this one time. You see how much it's scaled, so I'm going to hide the new one and I'm going to translate this one back. So again, going down to here, going to translate, I'm going to translate this element in the x direction and I'm going to translate it by 300 millimeters. So now it's moved back here. Press OK, hide that and hide that, and that's our first section. So you see it's sort of trying to come down here and sweep back. Now for the second one, I don't want it to stay within this axis. I'm going to create a new axis to do the second section. So back to my sketch pad, creating another line. There we go. And in this case it's going to be 1630. Not a huge change, but it can make quite a big difference when it comes to things like this because of the fact that it's much further up. I'm not going to rotate this one, I'm going to rotate this one around that axis. So again, back to rotation, I'm going to choose this element and I'm going to choose this axis, and this time I'm going to rotate it by 30 degrees, so I need a 330 degree angle. I'm not sure why it's choosing to be such an awkward cuss today. Press OK, and again I'm going to scale it and drag it back. So exactly the same operations last time. Extremum, element, direction X, minimum, OK. Scaling, element, reference, and this time I'm going to choose a ratio of 0.75. Hide that, translate it back in the X direction. And this time I'm going to translate it back by 540 millimeters. So you can see it's already we're already starting to make this this curve going backwards. And this is where we've gotten to then. So what I've done is I've done 4 sections. So to recap, I've rotated this one around an axis, translated it up, scaled it back. Same again, rotated it around this axis, scaled it down and pushed it back. And then all I did was offset this, scaled it back, offset this, scaled it back. And I've got these 4 sections which you can kind of see sweep back into this wingtip shape. Now obviously this is just by eye, there was no sort of calculations done on this one, just by eye to make it look good. So what we need to do now is create the guide curves. So the guide curves were created in exactly the same way we created the guide curves for the main wing box. So we need a series of points on each of these aerofoils, and the rib points at the back are already done for us. So again, all I need to do is create a series of extremums going in the X direction, and there we have it. So those are our 4 points. So now we have to create a spline. However, if we create a spline at the moment where it just goes from there to there, it's going to create a straight line, and we don't want the straight line to go from that point there to that point there. We wanted a continuation of this curve. Now there's 2 ways we can do it. We can either continue this curve directly and add it on, or we can just create a brand new one beforehand, of course, creating a point along here to anchor to. So that's exactly what I'm going to do in this case. So I'm going to create a point on this curve here, and I'm going to do a ratio along the curve. I want it to be about, let's say, 0.9, and that gives us a point there. And then do exactly the same on the other 2 curves over here. So we've now got our 3 points on our guide curve. So all we need to do now is create the spline going from each point like so, and you can kind of see it taking shape. And there's our finished splines then. So I've got 1, 2 and 3 splines, and they all match up with each of those all those sections. So all there is to do now is to do a multi-section solid and choose each section in turn, again making sure that the arrows are correctly aligned with each other, but as they're all translates and rotates of each other, they should be absolutely fine. Choose the guides, like so, and press preview, and there we have it. That's our wingtip. So with that done, obviously the way we did it in a totally parameterized way. So if you want to go back, you want to say choose that maybe 320, you can do it and it will just flit it back, no problem at all. And that's, again, probably not the best way to create a wingtip, but it's definitely one of the ways. And you can create a pretty good looking shape just from doing a series of translates and rotates around pretty arbitrary axes, to be honest. Okay, so that is our wingtip done. So what I'll show you now is that now we've got this entire surface and mass surface done on this particular wing. If I was to change something, it can cause quite a few problems because of the way things are linked to other things. So, for example, these ribs here only exist because of that line there. Now, in this tree, which can get quite big, it's very useful if you want to change something to actually just point to whatever you want to change, right-click it and go to Parents and Children. And this will bring up a subtree of what created the thing you just clicked on, so these 2 points, and what it actually leads to. So as you can see, this line here creates a lot of things. It responsible for all these lines, the bottom panel, these other lines, and another point. So there's quite a lot. If I was to get rid of this, it would cause a lot of problems. If I press delete, you can see what will light up and what will actually be deleted by this. So if it's a fairly simple change, you can obviously make that change quite easily. However, with some things such as surfaces or sketches or bodies, anything really, if you right click, you can click replace. And if you click that, you'll get this dialog box up. If you select what you want to actually change it with, what you will get is you will get this viewer coming up. And this is basically going to show you when you want to replace something, all the links it has to that particular element will need to be redone or re-linked. Now in this case we're lucky because what it's done, it's all green. It's found the edges. So this is the old, this is the new. It's found the old edges on the new one. So when it changes it, it's going to be linked up. So you press OK. You see the front spar has moved forward, and so has everything else with it. Now that's a good way of doing it, because what it does is specifically it replaces the links that are from other elements, such as the ribs, the spars. It replaces them explicitly. If you change something or just move a sketch to another place, you can miss some links, or some links can be broken, and you could find it quite difficult to fiddle around with everything to make everything the same as it was. So that's just a small tip in terms of replacing your sketches. Okay, so that is it for this this tutorial on CATIA V5. So that's pretty much the end of the basics of wireframe and surfacing. And what we'll be doing next is I'll be showing you how to kind of integrate the two together, and I'll be doing some more complex 3D modeling before this series will come to an end, and we go on to more specific series such as detailed design of wings, etc., etc. So I hope you've learned something today. As always, if you've got any questions or comments, please leave them down below. Do check out my Twitter feed for CAD clinic updates, and please do get involved. So thanks for watching. Cheerio.